Alright, in this video we're going to look at examples related to finding Riemann sums in calculation. Our first example here, example 3, comes to us directly from the 2012 AP Calculus BC exam. It's question number 4, which is a non-calculator question. We have our big lead-in, and then we're going to complete part B of this problem. It says to use a midpoint Riemann sum with two subintervals of equal length and values from the table to approximate the integral from 1 to 1.4 of f prime of x. And then we're going to use the approximation for that to estimate the value of f of 1.4. This is a non-calculator section, so we're not going to use our calculator on it. First, we look at what kind of Riemann sum we want. We want a midpoint Riemann sum, so we're going to choose the value of f prime at the midpoint of our subintervals. And we want two subintervals of equal length. So since our table extends from 1 to 1.4, we want the one subinterval to be from 1 to 1.2, and the other subinterval to be from 1.2 to 1.4. Now, how wide are these subintervals? They're 0.2 units wide. Okay. And we're going to get the heights for the rectangles from the value of f prime at the midpoint of the intervals. So for the interval from 1 to 1.2, the value at the midpoint, the value at 1.1 is 10. And so the area of that rectangle is going to be 0.2 times 10. And for the second subinterval, the value of the function at that midpoint is the value at 1.3. And that's 13. So the area of that rectangle is going to be 0.2 times 13. And so that's equal to 2 plus 2.6. And so, put approximate signs there. We're going to get that the integral from 1 to 1.4 of f prime of x is approximately 4.6. And we're going to apply what we talked about in the last video as far as net change. To find f of 1.4, we're going to take the value of f of 1 plus the integral from 1 to 1.4 of f prime of x. All right. If you look up in the table in the problem stem, you see that f of 1 is a known value of 15. So this is going to be 15 plus the value that we got using the Riemann sum. And so we're going to say that this is 19.6 is our approximation for the value of f of 1.4. All right. Our next example, example 4 from the 2011 AP Calculus BC exam, question number 2. This is a calculator section. We're given a table of data here. As a pot of tea cools, the temperature of the tea is modeled by a differentiable function. Values of h of t at selected times are shown in the table above. Using correct units, explain the meaning of 1/10 times the integral from 0 to 10 of h of t dt in the context of this problem. Now you should recognize this form. This is a form of average value. The average value of h of t is equal to 1 over b minus a times the integral from a to b of h of t dt. And so to explain the meaning of this, this is the average value And I'm not going to use average value. I'm going to say what h of t actually is the average. And what does h represent? H represents the temperature. Is the average temperature in degrees Celsius of the tea over the first 10 minutes that it's cooling. Since that's the time interval represented by 0 through 10. Okay, so there's the explanation of the meaning. The last thing they want us to do here is use a trapezoidal sum with the 4 subintervals indicated by the table to estimate that value. And so I'm going to go ahead and do that. We'll use a trapezoidal sum. So we're going to have 1/10 of the integral from 0 to 10 of h of t dt equals 1/10 times a trapezoidal sum. And to find the trapezoidal sum, we're going to use the width of each of the subintervals and then the average of its heights. So for the first one, we have a width of 2. The time ranges from 0 to 2, and the average of the heights. And then the next subinterval ranges from 2 to 5, so its width is 3, and then the average of the heights. The next time interval goes from 5 to 9, so its width is 4, and then the average of the heights. And the last time interval ranges from 9 to 10, so it's got a width of 1 times the average of the heights. Is this a calculator? Yeah, this is a calculator question. So I can use my calculator to go ahead and evaluate this value. And so I've got 1 over 10 times this quantity, 66 plus 60, because the 2's cancel out in that one, plus 3 times quantity 60 plus 52 divided by 2, plus 4 times the quantity 52 plus 44 divided by 3, plus the quantity 44 plus 43 divided by 2. Make sure I've got all my parentheses in the right place. Looks like it. And so we get 46.55. I type everything in correctly. 1/10 times 66 plus 60 is 3 times 60 plus 52 all over 2 is 4. Why did I put a 3 in that one denominator? It's like I lost my mind for a second. That should be a 2. Alright, let's go back and fix that. Alright, and now we get our average temperature of 52.95 degrees Celsius. Okay? I'm surprised you didn't say anything when I had that 3 in there. Maybe you did. I just can't hear you because this is a video. Alright, that's the end of this video on examples 3 and 4 from the net change and area review. See you guys next time. We'll tackle examples 5, 6, and 7 in that video. Have a great rest of your day.